I'm wanting to remind you of exponential rules. So I want to share the exponential rules with you, but I also want to develop some of the results of having the exponential rules. So the first one is called the product rule. If you remember, it's stated like this, that x to the a times x to the b is the same as saying x to the a plus b. And the quotient rule goes like this, x to the a divided by x to the b is the same as saying x to the a minus b. And then there's this thing called the power rule. And the power rule says x to the a raised to the b is the same as saying x to the a times b. Now there's a bonus that kind of comes along with this, because really this is the same as saying x to the b times a, then can also be written as x to the b raised to the a. So there's a little bonus that comes along with the power rule. As we're talking further, we have to recognize that there are other things that we need to talk about in exponential rules. One's called the zero exponent, and the zero exponent rule goes like this. We're talking about a and b, but what if a is equal to b? Then we can really pretty much say this, x to the a over x to the b is the same as saying x to the a over x to the a. But we already said that that's the same now as saying x to the a minus a. A minus a. Anything minus itself is equal to 0. So this is x to the 0 power. But if we look at this expression right here, we have a number that is divided by itself. And always a number when it's divided by itself is equal to 1. So we say then that the expression x to the 0 is always equal to 1. That means that anything raised to the 0 power is equal to 1, because it's just a number dividing by itself. That leads us to negative exponents. Let's do it this way. If we say that a is less than b, a minus b becomes some negative value. So if I say a positive c, then if I put a negative in front of it, you see that this is a negative number. Okay, so if we play with this now and we say x to the a over x to the b, we know that that already is equal to x to the a minus b, but we know that that's some negative number, so we can call that x to the negative c. Now this is really better shown if I do this with numbers. So let's let a be 2 and b be 5. So now we're talking about x to the 2 over x to the 5. Well, that's the same as saying x times x divided by x times x times x times x times x. And you see that we get some cancellation going on here, because this x cancels this x cancels this x. That puts a 1 on top, and I have x to the 3. So now we're talking about this being 1 over x to the 3. But that's positive 3. But that's the same as saying x to the 2 minus 5, which is x to the negative 3. So what we're saying then is that x to the negative 3 is the same as saying 1 over x to the positive 3. And I like to refer to that as jumping the bar. So if I had x to the 2 over x to the negative 4, that's really the same statement as saying x to the 2 times x to the positive 4, because now I've just jumped the bar and left a 1 down there below. So when we do that, then this ends up being x to the 6, because 2 plus 4 is 6. But if we look at it this way, it's x to the 2 minus negative 4. Minus negative, that's plus. So 2 plus 4, x to the 6. I hope that that helps, because the more that you understand your exponents and have a sense of what you get when you have multiple exponents, that the better that you're going to be in determining what your logarithms come out to be. So hope that helps, and thanks for watching.